project was requested by the Utah Avalanche Center. They are a nonprofit organization that's main purpose is to keep people safe from avalanches. Throughout the year, the Utah Avalanche Center does live classes to educate people about avalanche danger. During the class, they will set up a mini avalanche simulation by tilting a board with flour and sugar on it. They hold an inclinometer to the board and have somebody yell out the angle as the board is being tilted up. Once the material slides off the board, the teacher talks about the components that made the slide happen and relates it to real avalanches. The simulation is a great teaching tool, but the Avalanche Center felt like it could be improved. Some of the problems with the current avalanche board include that it's messy, not professional looking, small, not very repeatable, and difficult to raise and hold the inclinometer at the same time. The new avalanche board should have reusable material, be large enough for 100 people to see, be transported by one person in a car, and be lifted mechanically and display the angle of the board.
Here you can see the UAC analyzing the snow layers. The bottom layer is very fine and sugary. You can see that when he puts his hand right through the lower layer. The top layer is very heavy and dense, and the combination of this makes the top layer slide off. Looking for materials to represent snow is the main challenge taken on last semester. The Utah Avalanche Center used sugar and flour previously, which simulated snow well, but they wanted a reusable material. We started the search looking at relative densities and grain size, where the weak layer had a large grain size and smaller density, and the strong layer was smaller grain and denser. The first materials we tried were polystyrene beads, just add water poly snow, and even kitty litter. None of these had fractures like avalanches, and they did not slide at 38 degrees like the UAC wanted. The next couple of materials were sand chalk and wood chips wood flour, which performed better than previous sugar and flour model. These both slid at 38 degrees and fractured like an avalanche. The best overall option was the sand and chalk because they look more like snow as they are white, whereas the wood chips wood flour are brown, and it is easier to purchase. These materials are non-perishable and completely reusable to save on wasting material like before.
From the start, we knew this board would be big, heavy, and awkward to carry. One of our biggest design challenges was figuring out a way to transport the board effectively from one place to another. We based the design off a mix of a dolly and a suitcase, both of which are designed to carry large, heavy loads. Shown here is one of our preliminary mock-ups in SOLIDWORKS. The board itself is attached to an axle around which it can pivot when lifted. Just like the UAC's board, the snow material will be spread on the board and raised until an avalanche occurs. The board is designed to be narrow enough to fit through doors and light enough to be easily lifted into a car or trailer for easy transportation.
We wanted to make the board more interactive and fun because sometimes the classes are taught to kids. We decided to have trees on magnets that can be placed anywhere on the board. These magnets represent anchors in the snow and demonstrate how avalanche occurrence can change based on tree location.
In order to get the snow material on the board, we needed to develop a quick, easy, and clean way to disperse the material onto the board. We came up with what we call shakers, which are modeled after salt shakers. There are 2 shakers, one each for the strong and weak layers. Each shaker has a lid with dispersion holes, which allows for even distribution onto the board. The lids have different hole sizes, bigger for strong and smaller for the weak layer. First, a weak layer is applied, followed by a strong layer. Different layer thicknesses have different effects on the slope, angle, and slab performance of the avalanche. We can manipulate different combinations of layers and thicknesses to achieve exactly what we want.
The slope of the avalanche simulation is raised by a scissor lift mechanism connected to a lead screw. As shown, an 8mm shaft is mounted to the base of the board with 2 slide bearings attached to the shaft. Along the base of the 8mm shaft, an 8mm lead screw rod is mounted. This lead screw rod drives the slide bearings laterally with a connecting coupler to the smooth shaft. The smooth shaft takes the bending and vertical axial loads of the slope board to reduce the friction and torque needed for the lead screw. A motor is then connected to the end of the screw rod at one end, while a hand crank is connected at the other end. This allows lifting mechanism to work electronically or manually in case of a malfunction or no power source in the presenting area. The lead screw is driven and drives the scissor lift up and down, enabling the slope board to reach the desired avalanche slope angle.
There are 4 main parts of the electrical system: controls, display, motor, and logic. Controlling the logic is an Arduino Mega, which takes input from the 4 buttons, up, down, set, and reset, and provides output to a 2-amp dual H-bridge motor driver, which then powers a 2 Nm stepper motor. While this is happening, the Arduino keeps track of the angle the slope is currently at, and outputs that to a 6.5-inch tall, 9-inch wide display at the top of the slope. All of this is powered by a 10-amp, 12-volt power supply. The point of displaying the angle so obviously is to drive home the point that avalanches begin to occur at around 30 degrees, which is the main goal of the demonstration.
The UAC emphasizes that avalanches begin to occur at around 30 degrees and can occur at all angles up to around 45 degrees. If the angle is too low, it will not slide. If the angle is too high, the snow will continually slide so it cannot build up enough to cause an avalanche. Avalanches occur most often at around 38 degrees. The most common type of avalanche that involves human injury or fatality is a slab avalanche. Slab avalanches have a characteristic fracture which propagates across the slope to form a slab. This is what we want the simulation to accurately portray. The fracture needs to be an obvious crack along the slope. This can be seen here in the video.
One of the issues with the old board is that the material is messy and difficult to clean up. To solve this, we designed a bucket catch system. A bucket is attached to the bottom of the slope in order to catch the avalanche as it triggers. We use Zeus fasteners or quarter-turn fasteners to allow for quick release and attachment. This allows the material to be moved quickly during a presentation so no time is wasted and a new run can be set up quickly. The bucket itself needed to not interfere with the movement of the slope, so the bottom of the bucket was cut at an angle to ensure clearance and have enough volume to hold all of the material. Once a run is completed, the bucket can be quickly removed and either dumped straight into the filtering system or dumped into a bucket set aside for filtering later after the presentation is over.
A unique challenge of the project was the ability to reuse the snow materials. The UAC wanted to be able to run 2 to 3 demonstrations per avalanche awareness course. Unfortunately, after a demonstration, the snow layers are completely mixed and will not function again to produce a slab avalanche. We needed a way to quickly and automatically separate materials so that the UAC isn't burdened by buying pounds of flour and sugar for a demonstration. While researching soil filtration systems, a pre-built sieve vibrator was found and purchased from Gilson Company, a soil separation specialist. This pre-made vibrating mechanism was mounted to a 5-gallon bucket, and a funnel was fabricated to channel the filtered strong layer into a container to be dispersed again. The weak layer can then be sent down the same funnel into its container. The containers are magnetically centered and attached to the bucket. This filtering system can separate material within 15 minutes under ideal conditions. Last September, our team set out to perfect avalanche demonstration for the UAC and create a lasting teaching tool that can be taken to avalanche courses for years to come. We focused on creating a lightweight, portable, and reusable avalanche simulation that has a strong visual impact on students taking courses from the UAC. In those aspects, our project was a success.